Hey guys, welcome to the Purpose Discovery channel. This is where we help you get the right content. Keep watching and stay tuned.
Hello, welcome to Yomiterium YouTube channel. This is where you get the right content. Yes, let's head on to this year 2023 waec chemistry practical. Yes, this is the likely question you might see. A is 0.200 mole per dm cube ACl. C is a solution containing 14.3 gram of Na2CO3.xH2O in 500 cm cube of solution. Put A into the burette and titrate it against a 20.0 cm cube or 25.0 cm cube portion of C using methyl orange as indicator. Repeat the titration to obtain consistent titer values. Tabulate your result and calculate the average volume of A used. The reaction equation is given thus. So can you see the reaction equation? Okay. From your result and information provided, calculate the concentration of C in mole per dm cube, the concentration of C in gram per dm cube, in molar mass of Na2CO3.xH2, the value of X in Na2CO3.xH2. So we have to take H to be 1, C to be 12, O to be 16, and Na to be 23. Okay, let's head on to the solution straight off. So the first thing you have to do in your chemistry practical is for you to write indicator use. Can you see? Indicator use. Write your indicator use, which is methyl orange. That's what you are going to use that day. Then the volume of the base or the volume of the pipette is 25.0 cm cube. Then you are going to draw your table like this. Make sure there is no alteration in your table. So the rough, the first titer, the second titer, and the third titer. And if you like, you can just make use of first and second titer. But I'm making use of first, second, and third in this case. So the average titer value is first titer plus second titer plus third titer divided by 3. So average titer value is 25.003 cm cube according to my own calculation. So can you see? Okay, now let's go solving the question. So if you start solving the question, before you start solving the question, so we can see the equation for the reaction. And the equation for the reaction can also be in another form. So it can also be in this form. Check this out. Na2CO3 dot XH2O. So when you react with the acid ACl, you are going to have NaCl plus CO2 plus XH2O plus H2O. So 2 and 2. So the equation can also be in this form. Understand? The equation can also be in this form. It's another way whereby you can write the equation if you are given an unknown water of crystallization, unknown value for the water of crystallization. So you allow it to be in this form. Okay, let's add down to the solution. The solution to the question is thus: the first question, you have to calculate the concentration of the base in mole per dm cube. So if you want to calculate the concentration for the base, you are going to use a formula called CAVA over CBVB is equal to NB. Take note that my CB is the same thing as CC. So the concentration of the C, which is the same thing as the base. So I'm using the the concentration of the base as Cb, so which is C given to us from the question or given to us in the question. Now we have this. This is the formula CaVa all over Cb Vb is equal to Na all over Nb. So can you see the molar concentration of the acid was given in the question? So I'm going to display the question on the screen now. You will see it. Now we have 0.200 mole per dm cube, and the molar concentration for the base was not given in the question, so we have to calculate that. When you cross multiply, you make Cb the subject of formula. That's the concentration of the B, which is that of C. Now, volume of acid used is what you calculated from the table. Vb is that volume of pipette, and your equation gave you NaNb, the equation for the reaction. So if you calculate that, you will see that you are going to achieve a result of 0.1001 mole per dm cube. That is Cb. That's the concentration of C. So I told you that Cb, I've called it Cc, so which is the same thing. But on the exam day, you might be given as B instead of C as the base. So anyway, in any form you are given. Now, let's go to the second question. Calculate the concentration of C in gram per dm cube. So if you are calculating that, you will see what is given to us is 14.3 gram per 500 cm cube. Now you're going to convert that to gram per dm cube. How do you do that? You do it, you equate it like this and you cross multiply. Then you will now have an answer of 28.6 gram per dm cube. So if you have that, you can now go to the molar mass of Na2CO3.XH2 in order to go and know the concentration in gram per dm cube. So in order to know the molar mass, so because number 3, you have to calculate the molar mass. In order to know your molar mass, you make molar mass subject of formula here. So when you cross multiply, as I've written here, cross multiply, you are going to get molar mass as concentration in gram per dm cube over concentration in mole per dm cube. That is of C. So you put that, you already have that value. So you put that and you get this. So when you approximate this one, you are going to arrive here 2286 gram per mole. Now the last question asks us to find the value of x in that equation. This value of x. So if you want to look for that value of x, then it's very simple. Then your molar mass is 286. So you find x from that IUPAC formula. So when you do that using the molar mass illustration, you are going to have it as 18x after the dot. So 18x plus 106 before the dot. So it's equal to 286. So that is 286. Then you can now take this 106 to the other side, it becomes 108. Then divide through by 18, you are going to get 10. So that shows us that the base or the C that we have is Na2CO3.10H2O. That is our C. So you might be asked that what will now be the what will be the formula of C. So now we've gotten our X. So that is the formula of C there. So thank you very much. Click the subscribe button to subscribe for more, as I'll be displaying more information about the 2023 waec chemistry practical. Thank you so much. Subscribe to this channel. With this, you will help us to go even more further. Thank you so much. Subscribe, like this video, and share. Thank you so much.